sine, cosine, and tangent. We are going to get started by setting up the trig ratios. So sine, cosine, and tangent are our three trig functions, and each one is very specific on how it is set up and how we use it. So we're going to start with sine. Given the right triangle ABC with an acute angle A, the sine of A, written as sine of A, is defined as the opposite leg divided by the hypotenuse. So notice how I said ratio. This is a ratio. It's another word for a fraction. So if we're talking about this angle, angle A, remember your steps, circle your reference angle. Okay, and then the second step, label your hypotenuse. All right, and then I'm going to use green for the opposite leg. So we would go across. And this is the opposite. And that's all I need for sine. And then I would just write it. So what is the opposite segment? BC or CB. So BC divided by your hypotenuse, which is this segment, this side, AB. Let me change the color here so that it matches. Okay, now let's do cosine. Cosine is going to be cosine of A, so the same angle A. Cosine is going to be adjacent. So this is why we needed to learn how to label them first, and then now we can use the sides. Adjacent divided by the hypotenuse. Okay, so let's label our hypotenuse is still the same here. Across the 90 is the hypotenuse. And then adjacent, since I can't choose my hypotenuse for adjacent, I have to go this way. So this is adjacent. And then now I can set up my ratio. So adjacent divided by the hypotenuse. The adjacent leg inside is AC. Right here. I labeled it. And then divided by the hypotenuse, which is AB. Okay. And then now let's do tangent. Your tangent ratio of angle A. Tangent of A is opposite. The opposite side divided by your adjacent side. Okay. So let's circle our reference. This time we don't need the hypotenuse. So we just go opposite is over here. And our adjacent is right here. Again, this cannot be adjacent because that's the hypotenuse. And then we set up our ratio. So the opposite side is BC. And adjacent is AC. Okay. Now, when we start adding numbers to these will have lengths. Some of them will be missing. And we will write that instead of the name of the side. A very cool way to memorize these that a lot of math teachers use all the time is this SCT. So this stands for sine, cosine, and tangent. It's just so we memorize the ratios. So sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So, in other words, it reads SOHCAHTOA. I don't know who invented this, but it helps a lot of students. So, SOHCAHTOA, we're going to be hearing that word a lot, SOHCAHTOA. To remind you how to set up the ratio. So, again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse divided. And tangent is opposite over adjacent. So see how it matches the SOHCAHTOA? It helps me remember the ratio, the fraction. A key thing here that you need to remember is, do y'all remember what this is called? This is theta. Can't draw circles. Oh my god. Theta. And theta is your angle. Okay, that's what the theta is. That's your angle. So let's practice some more. Here are these trig ratios. I'm going to start with a sine of D. So let's go to D and circle it. And I'm going to write my SOHCAHTOA up here so that I don't forget it. So SOHCAHTOA. Write that down. So we know which sides to use. SOHCAHTOA. Okay. So angle D. The reason I know it's angle D is because it's right here. Angle D, angle D. Let's say our hypotenuse first. This is our hypotenuse across the 90. And then label your opposite and adjacent. So opposite is this 5 right here. And adjacent is this 12. For angle D. Okay, so then now I can set up my trig ratio. So sine is opposite over hypotenuse. So I'm going to write it here so we don't forget. So what is the length of your opposite side? 5. So 5 over hypotenuse, 13. Okay. Cosine of angle D. Cosine is ka, so ka, not ka, A-H, okay, not U-H. So adjacent over hypotenuse. So adjacent is the 12, hypotenuse is 13. So 12 divided by 13. Okay, and tangent is TOA, so opposite over adjacent. So my opposite side is 5. The adjacent length is 12. That's it. So this is just setting up trig ratios or fractions. I want you to pause the video and try to do these. Sine of f, cosine of f, tangent of f. Okay, pause the video and try to do it. Come back and check your work, okay? All right, check your work and make sure you did it correctly. If not, fix the errors and let's move forward. This is the main part of what we're learning today is solving for missing sides. So if we are very good at setting up the ratios, then the next step is to take it a step further where you're going to have a missing side in a triangle. And we're going to use trig to solve it. So I have the steps right here. Let's read it as we work on problem A. So it said to find a side, you need one side and one angle. Let's highlight that, circle it if you have a pencil. You need one side and one angle. So step one is always circle the reference angle. So let's circle it. Okay, label your given sides only. Your given sides only. The only sides that were given in the problem. So what side did they give me? If it's across the 90, what side is that? That's the hypotenuse. And then if I have to travel across the triangle, that's my opposite side. Okay? Now it says set up the trig ratio. And this is where you have to remember. So Katoa. Oops. So Katoa. Which one do we have? If we have hypotenuse and opposite. Hypotenuse and opposite. Which one of these three has that ratio? Those sides as a ratio. It's right here. Sine. So then we set up our trig ratio. Sine. And then remember this is theta. When we came here. This is your angle measure. So let's write our angle. What is our angle? Reference angle for this problem. We circled it. 36 is equal to opposite over hypotenuse. So opposite is x. Hypotenuse is 20. So this is what our equation looks like. So we set up our trig ratio. Check. Now solve for the missing side. And this is where our solving skills come in. So remember, solving for x, you need to isolate it, get it by itself. And right now it's being divided by what? 20. So how do you undo division? Multiplication. So multiply both sides, keep it balanced. Which allows me to cancel those. So nothing happens on this side. Now it's just x. And then this is the part where we get to have fun with our calculator. So we ended up with 20 times the sine of 36 degrees. Okay, so this is where you get Desmos. So open up Desmos on the side. And I'll show you. Here. All right, so let's put our calculator in degree mode. It has to be in degree mode. If it's not, check the toggle here. Make sure it says degrees. If it says radians, that's not going to give you the right answer. And then we just go for it. 20 times the tangent. No, not tangent. The sine of 36 degrees. And that gives me a decimal, so we do have to round. We're going to round to the thousands, which means 3 numbers after the decimal. So 11.756 is approximate. Oh, let's use our measurement. Sorry, this is inches. And that is how you solve a trig problem using trig. Okay, let's try this one. Circle your reference angle. We finished all the steps here, so circle a reference angle. Doing this one now. Label the given sides. So opposite. This is adjacent. Set up your trig ratio. So what sides did they give me? They gave me opposite and adjacent. So who has an O and an A here? O and A. Tangent. So the tangent of how many degrees? What's the angle? 25. Is equal to opposite over adjacent. 10 divided by x. So this one looks a little different because my x is in the bottom. But that's why I created this little scroll to help us. If your x is on the top, you will have to multiply. So the first one we did, you notice how my ratio ended up with an x at the top. What was the strategy I had to do? Multiply it. For this one, the x is at the bottom. So we're gonna be dividing the trig function. So I'll show you why we end up with division. We end up with division because right now the x is at the bottom and I need to get it alone. So how do you undo division? You multiply, right? Multiply both sides. So that allows me to cancel the x here. But then I'm stuck with it on the left. So we are here. And then how are you going to get rid of this multiplication? How are you going to undo this? X needs to be alone. So I'm going to divide by the trig function, tangent. Divided by tangent of 25. Both sides. So now they cancel. And we're left with x equal to 10 divided by the tangent of 25. So let's type that in our calculator. Divided by tangent of 25. So what does x equal? 21. Well, it's approximately, as we're rounding, 21.445. And this one was centimeters. So there we go. You're going to finish these 4 problems, the practice, and I will have a video maybe tomorrow or later on today on the answers for these. But if you're in class, or if you were in class, then you practice this and I probably already checked your work. All right, have a good day.